You are welcome to the GMAT 41's episode U2 past questions review. In this episode, we shall continue from question number 6. Remembering that in our episode U1 past question review of elementary mathematics, Math 102, Unisic examination, we start at question number 5. Remember to like and subscribe to our YouTube channel as we guide you in preparing you for your examinations. And don't forget to also inform and invite other friends of yours in order to subscribe and follow us up as we do this together. So here we have the 6th question, which reads, identify the stationary point of f of x equal to x plus sine x. We are to identify the stationary point of this function, f of x equal to x plus sine x. This is a problem extracted from differentiation. It's actually an application of differential calculus. And simply, to obtain the stationary point of any function, all you're expected to do is to differentiate that function and set it equal to 0. Just obtain the first derivative and make it equal to 0. Once again, before proceeding to solving this question, remember, if you have any challenge in the foundational aspect of this course, GMAT 41 is always there, alright, to make it 1 plus 1 for you, give you the background explanation and understanding of this course, and of course other science courses, so that you can follow through. So, come along as we solve this question, please. The function given to us is f of x equal to x plus sine x, and we are asked to obtain the stationary point. So, I'll go straight and obtain the first derivative of this function. So if I differentiate this x, alright, this dy, take note that f of x is the same as y. We generally say that, okay, y is equal to a function of x. Is that okay? So I can choose to still write this as d dx of f of x. Just this way. Differentiate with respect to x, that function which you call f of x. And in this case, it is x plus sine x. Alright, let's move on straight, please. All those are foundations of things, about differential calculus. The derivative of this x is going to give us 1, and then if you differentiate sine x, you're going to get cos x. I've obtained the first derivative, so simply set it equal to 0, because you're asked to obtain the stationary point. I'm going to say that it implies that 1 plus cos x is equal to 0, and then we shall solve for x. Doing that, cos x is equal to negative 1. Getting x, we are going to take the cosine inverse, is that okay, of negative 1. So x is equal to cos inverse of minus 1. Alright. Now, I'm going to say something. We have a video lesson in that anyway, what I call 0, 30, 15, 15, 30 degrees generator. Anyway, it's just something that can be used to determine the value of special angles. Alright? You can go through our YouTube channel and then you'll find out that video lesson that to watch, so that one can actually determine the value of cosine inverse of minus 1 even without a calculator. And so how do we do that? Okay, now for one thing, we know that cos 0 is equal to 1. Cos 0 is equal to 1, and 0 is in the first quadrant. Okay, and so if we move on to cos 180, this is 0, alright, and then here is 180 degrees. 180 degrees is in the second quadrant, okay, between the second and third quadrant. This is the first quadrant, and then this is the fourth quadrant. So, cos of 0 is equal to 1. So if I take cos inverse of 1, it should give me 0. Is that okay? And then, coming to this, you notice that 0 is linked to 180 directly. Coming to this second quadrant, between the second and third, you have 180. Cos of 180 degrees will give you minus 1. Minus 1. So if you take cos inverse of this, minus 1, it's going to give you 180 degrees. Okay? I've got a video lesson on this to guide you. Like I said, you can search through the GMAT 41 YouTube channel for the 0, 30, 15, 15, 30 degrees generator. And of course, you find what I'm talking about there. So let us go straight ahead. The value of cos inverse of minus 1 is 180 degrees. And this is the value of the stationary point. Okay? This is the value of the what? Stationary point, just to get the value of the variable in this function. And like I said, you have to differentiate, set the first derivative equal to 0 and solve for the variable there. Now, this answer we got, if you look at the option, is not there. There's not like 180 degrees here. We have -1, we have pi, we have 1, we have -2 pi, and of course, we have not and none of the above. But does that mean that the answer is not there? Take note that 180 degrees is equal to pi radian. Is that okay? Radian is also another value, another unit for measuring angles. So I can say that x is equal to pi. Is that okay? And this takes us to the correct option, B. We shall be moving on to question number 7. The 7th question reads, define G such that R is mapped to R. That means real number mapped into real number, by G of x minus 3 equal to 3x raised to the power 2 minus 2x plus 1. Compute G of 0. So this problem is extracted from functions and relation. Is that okay? And in this question, we are given a function which is called G, such that there is a linear mapping whereby a real number will still produce real number for you. You know the concept of domain and codomain. And now we were given that G of x minus 3 is equal to this function. Alright? We are required to compute G of 0. Now to compute G of 0 simply means in place of this x minus 3, we will fix what? 0. That's what it means. And you know, if I'm fixing 0 for x minus 3, what it tells us simply is that x minus 3 will be equal to 0. Now, what I'm trying to do here is simply get the value of x and then substitute into this function, this expression, and then I'll get my answer. But the value of x, which I will substitute into this expression to get the required answer, must be the value of x when x minus 3 is equal to what? 0. So that is just the approach to this problem. Let's go. We are given G of x minus 3 to be equal to, this 3x raised to the power 2 minus 2x plus 1. Computing G of 0 implies that wherever I see x minus 3, I will put what? 0. So x minus 3 is equal to 0. But unfortunately, there is no x minus 3 in this function, this expression here. The only way I can now approach this question, like I said earlier, is get the value of x at x minus 3 equal to 0, and then substitute it into this given function. So let us do that from here. You see clearly that the value of x is equal to what? 3. So what is the implication? Obtaining G of 0 simply means we should go into this function, and wherever we see x, we will fix what? 3. Because this x equal to 3 is the point at which x minus 3, this whole term, is equal to what? 0. So doing that, we're going to get, in this function here, 3 brackets, x is equal to 3, so I'll fix 3 there, raised to the power 2, minus 2 times 3, because x is 3, and then plus 1. Simplifying this, 3 raised to the power 2 will give you what? 9. 9 times 3 is 27. Then 3 times 2 is 6. 27 minus 6 is 21. 21 plus 1 would give us 22. Therefore, the value of G of 0 is equal to 22, and that goes with option B. We're moving again to question number 8. And the 8th question reads, determine the maximum point of x, open bracket, 12 minus 2x. This question here is extracted from differentiation. In fact, it's an application of differentiation. However, before I move on into this question, I'd like to state that for the concept of maximum point of a function, minimum point of a function, and of course point of inflection, remember you can always contact the GMAT 41 in order to join our full range of learning classes to get the basic foundation of minimum, maximum, and point of inflection. Because I'm going to limit just the explanation to what we have here, alright, since we're just solving past questions. Let's go. We are to determine the maximum point of this function. Let me call the function y, and the function y is equal to x, open brackets, 12 minus 2x. Now, all we need to do to get the maximum point of any given function, it is simply the value of the stationary point for which the second derivative of that function is less than 0. Listen again. The maximum point of a function is simply the value of the stationary point for which the second derivative of that function is what? Less than 0. So that tells you what it would be. Suppose it was minimum point that we are asked to find. It will be the value of the stationary point for which the second derivative of that function is what? Greater than 0 in the case of minimum point. Anyway, let us focus on the business here. We are looking for the maximum point of this function. So let us proceed to obtain the stationary point of this function quickly. And so I will do the first derivative first. I can differentiate this using product rule because this is x times this bracket. But I wouldn't want to do that for this function because this function is pretty a simple one. You see, this bracket is raised to the power 1. This term outside here is so simple, just x. It is not x plus anything or x minus anything in bracket and other things. So I don't need to punish myself using product rule here. I would simply open up this bracket to get 12x minus 4 minus 2x squared. And so I would differentiate this term instead, straight on. If you differentiate 12x, you get 12. Differentiate this minus 2x squared, you're going to get 4x. At turning point, what do? I am going to set the first derivative equal to what? 0. From here, I can solve for x. To solve for x, simply move minus 4x to the right hand side, you get 12 equal to 4x. And then divide through by 4. If you do that, x is equal to 3. X is equal to 3. Now, since it is only one value we obtained here, only one value, x equal to 3, it simply means that this value of the stationary point, x equal to 3, is actually the maximum point of this function. I don't even need to go and do the test of second derivative again if I am inside examination hall. The answer here is simply 3. Okay, for this case, however, I want to be very careful, and so I usually advise get to the end. Get to the end because it is possible, again, that this point may not be the maximum point. It depends on what you get as the value of the second derivative. So please, let's get to the end. Second derivative, the 2y d squared x, okay, will be equal to, that simply means I have to differentiate the first derivative. And this is what I obtain in the first derivative. If I differentiate this term, I will get 0 here. And then this minus 4x differentiated will give me minus 4. Did you take note that the second derivative value here is minus 4? This is less than 0, is that not so? That minus 4 is less than what? 0. So what does that tell us? Remember, I defined the maximum point of a function as the value of the stationary point, which would make the second derivative of that function to be less than 0. And you see it clearly for this function. The second derivative is already less than 0. Therefore, this stationary point value, which I got x equal to 3, is a maximum point. The correct option for this question is option D. We are moving on to the next question, number 9. Question number 9 reads, if 2y raised to the power of 3 minus x raised to the power of 2 is equal to 4xy, then find dy dx. Once again, this question is extracted from differential calculus, differentiation. But it's important for us to take note of the nature of the function given to us. This function is an implicit function. Is that okay? It's an implicit function. And so to obtain our dy dx, well, I'm going to teach you something very interesting about implicit function, okay? You can use a direct approach to obtain it, going by the formula, which I call the Omakars del F formula. The Omakars del F formula. So we're going to do that. Follow along as I show you how to handle that. In solving this question, first, I am going to call the function a function of x and y. And then it will be equal to, this is what I will do. I will move all these variables, all these terms to one side. Okay? Either I move all of them to the left or I move all of them to the right. Now I prefer to move this to the left. So this 4xy will cross over to these terms. And we're going to get 2y raised to the power 3 minus x raised to the power 2, then minus 4xy. This is what I am going to get now. So I call this function a function that depends on x and what? Y. And then I will apply the del f formula. Okay, so getting my dy dx, because we are asked to differentiate, to find dy dx. Dy dx is simply negative del f del x all over del f del y. So this is the formula I call the hallmark del f formula. You see, the idea here is that we are using the concept of partial differentiation and to solve this question, and then you get your answer just straight on. Follow along as I differentiate these templates. So what's going to be our dy dx here? Dy dx will now be equal to, now watch, I will be differentiating this function which I call f. Look at it now. Following the numerator, first, partially with respect to x, del f del x. So when I'm differentiating this term partially with respect to x, y will be taken as a constant. So we go negative, open bracket. There is no x here, so if you differentiate this, you're going to get 0, this 2y raised to the power 3. Then come over here, negative x squared, differentiate this x, you're going to get minus 2x. And then next, come over to this, minus 4xy, there is x here, so you keep the minus 4y constant and differentiate this x, so you're going to get minus 4y. Minus 4y. I'm done with the numerator. I'm going to divide this term around, partial derivative of that function I call f with respect to y this time, which means that x is going to be kept as constant. We go. We've got y in this term here, so we're going to differentiate this to y raised to the power 3, partially with respect to y. If you do so, you get 6y raised to the power 2. Coming to this term, this is minus x squared. There is no y term here, so this is a pure constant. Derivative of this term with respect to y, partially, will give us 0. So it goes up. Coming to this, differentiate this partially with respect to y. So you're keeping this y constant, this minus 4y constant, and then, alright, you are keeping this minus 4x constant, because you are differentiating the y term now. Are you following? Keeping minus 4x constant, and then differentiating y, you are still going to get minus 4x. Because the derivative of that y with respect to y here will give us 1. 1 times minus 4x is minus 4x. Now all I have to do is simplify this term now. I've obtained my dy dx. That's the answer. But I'm going to simplify so that I will get an option that I have here, because that is not directly here. Okay, now with this, if you look at this term, this minus can open up this bracket. If this minus opens up this bracket, it will change this minus to plus, change this minus to plus. And then take note that 2 is common to this term here. So I can factorize the 2 out, and then we get something like this, x plus 2. X plus 2y. So watch, this negative will change these signs to positive. 2 is common, bring out the 2. This will be the term left in bracket. Then divided by, in the denominator, something similar as well too. 2 is common to the 2 terms here, this and this. Factorize the 2. What will be left here will be 3y squared. What will be left here will be minus 2x. And then you see that these 2 will cancel out. Conclusion, dy dx is simply equal to x plus 2y divided by 3y squared minus 2x. And so we're going to the options to check which one is the correct answer. Option A is the correct answer because x plus 2y is the same as 2y plus x. And then 3y squared minus 2x. Option A is the correct option. We are moving on this time around to the 10th question, which will mark the end of episode U2. Find the domain of square root 16 minus x squared. This question is extracted from functions and relation, the concept of domain of a function. Square root of 16 minus x squared, we are asked to find the domain. How do we solve this problem? The function given to us is square root of 16 minus x squared. For a given function as this, to obtain the domain, you are expected to set the term inside that square root to be greater than or equal to 0. Because it is only under that condition that you can get a number whose square root will be a real number. And that helps us to obtain the domain. Therefore, I'm going to say that it implies that 16 minus x squared is greater than or equal to 0. This term is a difference of 2 squares. So it's the same as 4 squared minus x squared greater than or equal to 0. And you know we can factorize this term. To factorize this term, what are we going to get? we are simply going to obtain that 4 minus x in bracket, then open bracket, 4 plus x in bracket is greater than or equal to 0. Now, at this point, it's important for us to take note of something. This is not an equation. This is an inequality. Are you following, right? We need to interpret this. We are told that this bracket times this bracket should be greater than or equal to 0. Under what condition can you multiply two terms so that the result will be greater than or equal to 0? Two cases can be identified. And generally, out of these two cases, one usually wins at the end of it all. Now, for you to multiply two numbers or two terms so that their product will be greater than or equal to 0, these are the conditions. Condition number 1 is that each of them is greater than 0. That is, this will be greater than 0, this will be greater than 0. Or, of course, equal to 0 in the case of both of them. Then, the second condition would be that, okay, each of them is less than 0. This will be less than 0, this will be less than 0. Are you following? So under that case, if you multiply these two terms, you can either get something that is greater than or equal to 0. Is that okay? In the GMAT 41's YouTube channel, we'll have a full video explaining this concept. You can please search for it, alright, on a playlist, and you can find a video to get a full understanding of this term, because I'll be going straight on to just solve this question. Now from here, what do you have to do? In case 1, we can say that 4 minus x is greater than or equal to 0, or 4 plus x is greater than or equal to 0. So in both cases here, we've considered that each of them is greater than or equal to 0. And so this is going to give us that 4 is greater than or equal to x. And you know the implication of this. It simply means that x is less than or equal to plus 4. That's what this is. Or, at this point, we can say that x is greater than or equal to minus 4, if this crosses, okay? Now, let us look at this condition and see if it makes sense in real life. A number is given to you, we call it x. That number is less than or equal to positive 4. That same number is greater than or equal to negative 4. Is that possible? Can you have a number which is greater than or equal to, say, minus 4, but that number is less than or equal to 4? The answer is yes. We can have such number. Think about the number, let's say 2. 2 is greater than minus 4, but that 2 is less than what? Plus 4. Is that okay? And so this case is acceptable. And this is where our answer lies. We can now conclude based on this question that the domain is equal to negative 4, 4. Please take note that this could still be written as domain is equal to negative 4 is less than or equal to x, but that same x is less than or equal to 4. This could also be the domain. Are you following, right? In terms of range. In terms of what? Range. And this is how we come to the end of this episode. Here we have the correct answer to be option A. In our next episode, U3, we are going to continue to solve from question number 11. Remember to subscribe to our channel and then follow us so that we can guide you. Also inform other friends of viewers, alright, as well as your colleagues, in order for them to also subscribe to the GMAT 41's YouTube channel, for there are a lot of things you can learn from there in sciences and engineering at all levels of education. See you in our next class.